They rest where light dissolves into shadow, along the sandy plains of warm tropical seas. For long stretches of time, they are almost invisible, motionless, patient, part of the seafloor itself. And then, in a single, explosive moment, they transform. Wings burst open in a sudden flare of color. Electric blue, neon green, deep violet. Patterns so vivid they seem impossible in the muted world beneath the waves. This is the flying gurnard. Not a bird, not a glider, but a fish that has mastered the art of illusion. The flying gurnard, Dactylopterus volitans, inhabits the warm coastal waters of the Atlantic Ocean, ranging from the eastern coasts of the Americas to parts of West Africa and throughout the Caribbean Sea and Gulf of Mexico. It prefers sandy or muddy bottoms near reefs, seagrass beds, and continental shelves, typically at depths ranging from shallow coastal zones down to around 100 meters. These environments are dynamic, constantly reshaped by currents, tides, and shifting sediments, and survival here demands both adaptability and precision. At first glance, the flying gurnard appears rugged, almost armored. Its body is covered in bony plates that provide protection against predators. Its head is large and angular, with a wide mouth and eyes positioned to survey both the seabed and the water column above. But the true marvel of this species lies folded against its sides, its enormous pectoral fins. When extended, these fins form a broad, semicircular wing that can span wider than the length of the fish itself. Unlike true flying fish, which glide above the water's surface, the flying gurnard never leaves the ocean floor. Instead, these fins are used primarily as a defensive display. When threatened, the fish rapidly spreads them outward, revealing a striking pattern of iridescent spots and bands. Color plays a complex role in the life of the flying gurnard. When at rest, its body is relatively subdued, earthy browns, grays, and mottled patterns that blend seamlessly with sand and debris. This camouflage is essential for avoiding detection by predators, but when its fins are unfurled, the transformation is dramatic. The vibrant colors seen in the wings are produced by specialized pigment cells and structural coloration, which manipulate light to create shimmering effects. These patterns are not random. They are evolution's answer to a specific problem: how to survive in a world where visibility can mean vulnerability. Despite their name, flying gurnards are not closely related to true gurnards of the family Tryglidae, although they share some similarities in body structure and behavior. They belong to the family Dactylopteridae, a distinct group characterized by their enlarged pectoral fins and walking rays. This evolutionary path highlights how similar environmental pressures can lead to comparable adaptations in unrelated lineages, a phenomenon known as convergent evolution. Life on the seafloor is not easy. It is a world of constant competition, where food can be scarce and danger can come from any direction. The flying gurnard's strategy is one of balance: remain hidden when possible and become overwhelming when necessary. Reproduction in flying gurnards follows a pattern common among many marine fish. They are believed to be pelagic spawners, releasing eggs and sperm into the open water, where fertilization occurs externally. The fertilized eggs drift with ocean currents, becoming part of the planktonic community. This stage of life is one of extreme vulnerability, where only a small fraction of individuals survive predation and environmental challenges. Those that do survive undergo a transformation of their own, developing the distinctive features that define the species. As they mature, they transition from a pelagic existence to a benthic lifestyle, settling onto the ocean floor where they will spend the rest of their lives. The sensory world of the flying gurnard is finely tuned. Like many fish, it possesses a lateral line system that detects changes in water pressure and movement. This allows it to sense approaching predators, nearby prey, and even the subtle disturbances caused by shifting currents. Combined with its tactile legs, this sensory network gives the flying gurnard a detailed understanding of its environment, even when visibility is low. Sound may also play a role in its behavior. Some related species of gurnards are known to produce grunting noises by vibrating muscles against their swim bladder, while less is documented specifically about Dactylopterus volitans. It is possible that similar mechanisms exist, contributing to communication or deterrence. Encounters with flying gurnards in the wild are often brief but unforgettable. Divers describe the sudden unfurling of its wings as a moment of shock, a flash of color in an otherwise muted landscape. It is a display that feels almost theatrical, as though the ocean itself has staged a performance. And yet, this display is not for us. It is a survival mechanism, honed over millions of years of evolution. Every color, every movement, every structure serves a purpose shaped by the relentless pressures of natural selection. The evolutionary origins of the flying gurnard trace back to ancient lineages of ray-finned fishes, a group that has diversified into an astonishing array of forms. Within this diversity, the flying gurnard stands out as a testament to the creative power of evolution, proof that even within the constraints of a shared body plan, life can find extraordinary solutions. In modern oceans, however, even the most specialized adaptations may not be enough to guarantee survival. Coastal habitats are among the most impacted by human activity. Pollution, sedimentation, overfishing, and habitat destruction all pose challenges to species that depend on these environments. Climate change adds another layer of uncertainty. Rising sea temperatures, ocean acidification, and shifting current patterns can alter the distribution of prey and the structure of habitats. For a species like the flying gurnard, which relies on specific environmental conditions, these changes can have significant consequences. Despite these challenges, the flying gurnard remains a relatively resilient species, in part due to its wide distribution and adaptable feeding strategies. But resilience is not immunity. The health of its populations is closely tied to the health of the ecosystems it inhabits. To protect the flying gurnard is to protect the sea floor itself, the vast, often overlooked landscapes that support an incredible diversity of life. These habitats are not empty expanses, but complex systems where every organism plays a role. The flying gurnard is one of those roles, a hunter of the hidden, a master of disguise, a creature of sudden brilliance. It walks where others swim. It hides where others hunt. It transforms when others flee. In a world where survival depends on both subtlety and spectacle, the flying gurnard has mastered both. And perhaps that is why it captivates us. Because it reminds us that the ocean is still full of mysteries, creatures that challenge our expectations, behaviors that defy simplicity, and stories that remain largely untold.